Okay, so for our last example, calculating wavelength and frequency for electromagnetic radiation, another reminder, we're operating with a constant of 300,000 meters per second as this velocity of visible light in a vacuum. And we are, in this case, our problem says calculate the wavelength of a FM radio wave for the station channel 933, which broadcasts at a frequency of 93.3 times 10 to the 6 hertz. So let's take a look at that problem. So first we do our drawing. We have a frequency and a velocity, so we don't really have anything to label. So let's list our variables. We know that our frequency is 93.3 times 10 to the 6 hertz. And we know our velocity, which is a constant of 3.0 times 10 to the 8 meters per second. And we are calculating, this time, wavelength. So if we're calculating wavelength, we can come up to our triangle, cover up the wavelength variable, and we see that we're calculating with velocity over frequency. So that is going to be our formula. And I'm going to move this up so I have plenty of room. So my formula is going to be wavelength is equal to velocity over frequency. So now that I've written out my formula, F in the diff-sow, I'm going to solve by plugging in my known variables. So 3.0 times 10 to the 8 meters per second over my frequency, which is 93.3 times 10 to the 6 meters, sorry, not meters per second, hertz, which if we remember, we can use for our hertz, we can use the per second as a little shortcut to help us with our unit canceling at the end. All right, so it's my wavelength. First thing I'm going to do is do the division on my numbers, right? So if I do the math, I should come up with an answer that is 0.0321543. Okay, so next step is I'm going to work with my exponents. So I subtract 8 minus 6. So if I take 8 minus 6, I'm going to come up with 2. So times 10 to the 2. And then my last step is to figure out my units. So remember, I get to cross cancel my S's, and I'm left with my M. So that's going to give me a unit of meters. So as it stands right now, I have an answer, but it's not in correct scientific notation. So I need to switch it to the correct scientific notation. So my decimal place is right here. And I'm going to be moving it 2 times so that it sits right after the first non-zero number, so that I only have one value in my whole number space. So that's going to give me a wavelength of 3.2 times 3.21543 times 10 to this. So I had a 2 in my exponents location right here, but I moved my decimal over 2 times, so that 2 now becomes a 0 because I moved it over twice. 0 meters. So you could leave it like that. I would accept your answer like that, but maybe most of you already know that 10 to the power of 0 is equal to 1. So if 10 to the power of 0 is equal to 1, then this is times 1. So I could also write my answer as 3.21543 meters. And I would take either one of those as a correct answer. So you could draw a line around either one of those. Let me move that just to make sure you were able to see the last sort of bit right there.